Hello all, so now let's continue with the fourth case. I hope you all have tried this. Now you can see that the left hand side is at positive potential, whereas the right hand side it has negative potential, right? Let us assume that this is the ground. So we can say that left hand side is at plus V potential as compared to right hand side, since we have assumed that the right hand side is connected with the ground, correct? Now let's draw the band diagram. Now see correctly what will happen over here. Since over here now the current will be flowing, so direction of current is like this, correct? This is the current I. So obviously the direction of electrons will be opposite to that of current, as we all know. So electron flow will be from right to left, and as we all know, electrons will flow, okay, in direction that is from higher potential to lower potential. So it clearly says that there will be a slope in the energy band diagram. Okay. Why? Because the energy of the electrons on the right hand side, that is the potential, as E equals to QV. Okay. They are directly proportional. So the potential of the electrons on the right hand side is higher than the electrons in the left hand side. So that's why electrons move over the direction from right to left. Okay, so electron move from through this direction. Okay, like this. So obviously there will be a slope. So let me draw a slope. Clear? It is up till this only. Please note it is same as the cases we have seen above. So this will be our E top. This will be our EC, correct? And similarly, we can plot this one, that is our EV and E bottom. So this is EV and this is E bottom, correct? So now you might wonder, what is the value of this slope? What if we need to calculate the value of this slope? So let's calculate that. So obviously, as we all know, the slope is change in y-axis upon change in x-axis. Over here, the x-axis is our distance, right? So directly we can write slope can be given by d EC by dx. Okay, and what is the value of this slope, or we can say what is the unit of this quantity? We will be talking it about, okay, in a minute. But before that, let me revisit again to this slope. So clearly you are seeing that over here we have slope. This is our EC, right? And E top. This is having slope. Similarly, this is EV and this is E bottom. Now you may wonder that this is slope. So as compared to this case, compare this case with fourth one, right? Over here we don't have slope, right? Over here also we don't have any kind of slope. But here you might ask whether the slope is, suppose initial condition was like this, then it has moved like this point has moved upward or this point has moved downward. What has happened? You might wonder, right? So you can clearly see that the initial point was this, okay, this one, and now we have moved downwards. And how much we have moved downwards? Obviously Q times V, since you can compare with the case number 2 that over here the left hand side is connected with the positive potential. So we have moved downwards due to the reason that E equals to QV, and over here Q is minus V and V was positive. So overall we are having negative. That's why we have moved downwards. So over here also we have moved downwards. So this, okay, we have moved actually downwards, and this value by which the energy is being lowered is Q times V, correct? This one. And similarly, this value from which we have moved, okay, this is also q times v. So this value has moved downwards, okay, and that's why, suppose initial case was like this, now this had moved downward, so we are having like this, okay, this had moved downward, so overall energy will have like this, okay. Don't do that this has moved upward, it will do, this is at this same point, initial point, and if we move it upward, then from this initial point we will move upward. It is not like that. This energy was initially over here, and now this point has moved downwards, and this is now our point, okay. So this is the method how to plot a energy band diagram in case of current flowing through the semiconductor. And always note that whenever there is a current, please note that whenever there is a flow of current, you will always get slope in energy band diagram. So in options, if there are options which don't have any kind of slope, just neglect them if the condition is of closed circuit, that is current is flowing through the semiconductor. Now let's revisit to this slope, okay. As we all know, this slope is dEc by dx, and we know that this EC is the energy and x is the distance, okay. Energy unit is, as we know, E equals to QV, so its unit is coulomb into volts, right? So it is coulomb into volt per meter, correct? Now this is the unit of our slope. Now what we want, what if we want the electric field from this slope, as we are interested in finding electric field. So how we can get, you can clearly see that we know the unit of electric field is volt per meter. So just if we divide this unit, that is this thing, by charge, okay, directly we can get electric field, correct? So the electric field, okay, this is electric field, is given by dEc by dx just divided by q, okay. And if you want to derive this, you can derive it in an alternate way also, like this. Just follow me. Let's say we know E equals minus dV by dx. Electric field is gradient of potential, negative gradient of potential. So minus d by dx, V is given by EC by q. But since here q is the charge of electron and it is negative, so I am writing this q just as magnitude and writing negative sign, okay, against it, okay. Negative sign is taken upward. So this negative and negative will be cancelled and we are left with overall positive. So since q is constant, we are left with dEc by dx, which is nothing but our this equation. And on a similar note, you can write electric field as same 1 upon q d EV by dx also, because since EV and DC both are having the same slope. And one more important point, that in energy band diagram always EC and EV, okay, are parallel, okay. There is one more thing we plot in energy band diagram, it is Fermi energy level. All these things Fermi energy level will be discussing in just next lecture, okay. So always EC and EV are parallel, so please remember this points. So in any options, in any kind of question, if there is no parallelism, okay, between EC and EV, then just neglect those options, okay, they can never be correct. Clear? So that's all how to plot the energy band diagram, right? So thanks a lot. Do comment, okay, if you have any doubt.